We're going to start in 5 minutes. Can everybody hear me? Hello, everyone. Today we're going to have a testing. We're going to cover some new topics, but we're going to review rational function problem we done before. So I have two problems here. The first one we have is a fraction. So we have to figure out if we're going to do as a ln or we're going to change this to be an exponential function form. Right? So how can we check that? We learned before that is we look at our denominator. So our denominator right here, x plus 1. The exponent on the we have the degree is 1. So whenever degree is 1, we're going to consider this is a rational function. So when we have rational function, we check the degrees. So right here, degree 1, the second problem we have, the degree is 3. So when it's degree 3, we're going to change this one, the second one, to be exponential function form. So that's going to be -3. So the first problem we don't have to change. We're just going to continue to use a ln. Right. So we first has to find our u. Our u will be x plus 1 for both. This is my base. This is my denominator. So we're going to try the u prime method to see if it's going to work. So the u prime for the first one is 1 because the derivative of x plus 1 is 1. Of course, second one is the same, right? So u prime x plus 1 derivative is 1. So since it's 1, we don't have to do anything. So first one we are done. That's going to be a ln. Give absolute value x plus 1 plus the c. The second one we're going to use the power rule to follow the formula that is going to be x plus 1 -3 plus 1 over -3 plus 1 plus the c. course, the problem cannot be that easy, right? So we introduced something new last time, that if we have the same degrees, which we showing x over x plus 1 dx. When we face this problem right here, we first look at our denominator, right? So for the whole denominator right here, degree is 1. So we are thinking about this is a problem for rational function. However, we have x on the top. If we try u prime, which supposed to give us 1, but we do not have 1, and we cannot make it because we have x on the top. Now we switch to different ways, that since we have the same degree, we could solve this by using long division. Alright, so let's do the long division right now. Remember, do the long division, we go x divided by x plus 1. When we solve a non-division problem, we have to make sure we have all the terms, including the constant. So I'm going to put a 0 right here, right? So from the highest degree to the lowest, so then constant. So we're going to use 1 right here, because 1 times x is x. That's match the first term, plus 1. Now we have everything prepared to do the subtraction right here. It's up to you how you do it. You can change the sign to adding, but here we're going to do a subtract. Right, so I'm doing subtraction. X going to cancel out. 0 minus 1 is -1. We're going to rewrite this so we can prepare for showing us how this is going to be given us. That's going to be 1. Remainder is -1, so that's going to be plus -1 over x plus 1. After we rewrite this fraction, we are able to continue to do the integration. Or I showed a special method last time. Remember, we can change the top. We can change the numerator to be x plus 1 subtract 1. The reason I'm showing this because we're going to go over completing square today. Right, this is what we need to do it. So after I plus minus 1, so basically I create x plus 1 by myself. So now we are able to reduce. So I'm going to have two fractions come out. First one is x plus 1 on the top. Next one is -1 on the top. So x plus 1 over x plus 1 is 1. So 1 plus -1 x plus 1 dx. So both methods give us the same result. On the exam, it's up to you how you do it, right? So it looks like the second method is faster, but doesn't matter how you're going to do it. We're going to get the same result. Now we can keep on changing different functions. Then we have to figure out what's the best method for us to solve it. Now we have a new problem right here. We have a fraction and our denominator right here is very clear. That's the exponent to be 1. So that's going to be looking at a rational function form right now. U prime is not going to work because the degree on the top has x squared. That's higher than my degree for the x plus 1. Whenever the degree on the top is higher than the function degree on the bottom, we're going to do long division. Right, so if they all have the same degrees or the top one is higher, we can just do long division to reduce the fraction. Then we can continue. I'm just going to review long division for you to see how, just like a review for pre-calculus. We're going to have a long division sections for student taking pre-calculus and 206.5 and a BMCC. If you think your long division is not good enough, you can go to that sections so you can get a lot of help. So when we do long division, we have to see what we divide. So we divide by x plus 1. Right, it's two terms. I'm going to use the first two terms. We're going to match the x squared, the highest degree term. So in order to get the x squared term, I have to times the x for x plus 1. Because x times x is x squared. Right, we are doing multiplications. 1 times x is x. We are doing subtraction right here. I subtract. X squared gonna cancel out. 2x minus x is x. Now I have x. We are doing two terms, so I have to bring down one more term, so that's negative 5. Then we have to match the first term x. In order to match that, I'm going to use the 1 because 1 times x is x. 1 times 1 is 1. Now we do a subtraction right here. X cancels out. Negative 5 subtract 1, negative 6. Now we can rewrite our original fraction. So that's going to be our x plus 1 we get plus the remainder we have. That's going to be plus negative 6 over x plus 1. So that's the whole thing we have. Now let's relook at our division. After our division, the problem is very easy to solve right now because it's very easy to solve the first part, x plus 1. That's going to be x squared divided by 2 plus x plus integration of the negative 6 over x plus 1. That's very basic rational function. Right, I can put the negative 6 in front. Then I just do 1 over x plus 1. So this is going to give us a ln of x plus 1. So I'm going to continue right here. I just copy it. That's x squared over 2 plus x minus 6 ln of x plus 1 plus c. So you don't have to worry about the first exam, right? I'm gonna post the first exam information on Blackboard. So you're gonna have a few hours to finish exam at home. So it's gonna be a take-home exam, right? So I probably gonna post next week. So you still have a lot of time to study. But the topic we have today is not gonna be on exam. Any questions so far? So we do integration of x, right? That's gonna be power is 1. So when we do power of 1, that's gonna be using your basic formula to do x to the nth power. That's gonna be n plus 1 over n plus 1. So here that's gonna be x squared, because 1 plus 1 over 1 plus 1. That's going to be x squared over 2. Now let's work on something else. So two problems we have right here are very similar because we have the same numerator 1 and the denominator is x squared minus 4. The next one is x squared plus 4. The first thing we want to know is, can we use u prime method for both? Right, u prime is the first thing we try. So in order to know how to use u prime, we have to check our degree for the denominator, right? For the whole denominator, degree is 1, so this is considered to be rational functions form. So for the rational function form, our u will be the whole denominator, which is x squared plus 4. So for the x squared minus 4 or x squared plus 4, when we take a derivative, that's going to be 2x for both. We cannot make a 2x. We can only make a constant number right now. So for both problems, we are not able to use the u substitution shortcut. So for the problem number 1, the first thing we want to do is, can we do factoring? If this one we can do factoring, that's going to be partial fraction problem, which we did last week. We did last time, right? The second one, can we do factoring? So the first one factoring will be x plus 2, x minus 2. How about this one right here? I have x squared plus 4. So now we know there's something, we have a problem right here for the second problem, because x squared plus 4 cannot do factoring. That means that's not partial fraction problem. We're going to go over a partial fraction problem first, then try to solve x squared plus 4. Right, so let's go over the partial fraction for the first one. When we do the partial fractions first, we have to rewrite. Right, so for the partial fraction, we have 1 over x squared minus 4. We're trying to set up two fractions for it, because we know the two factors. Right, so that's going to be, one is a, because x plus 2 is linear function. The second one will be a b, because x minus 2 is also linear. Once we have a and b, we are able to solve it, right? Because a, think about this is a constant, this is constant. That's going to be a very basic integration problem, because the rational function right here, I just use the u prime, and the u prime will be 1. Right, so now is how we get a and b. Let's go over that. So in order to get a and b, I'm going to rewrite there are two different ways to solve it. So I'm going to show you the first way. I think I did this in class. Then I'm going to show you the second way. Right, so the first way we're going to do is we have to first combine the two fractions. Right, so the common denominator is x plus 2, x minus 2. And for the first fraction, we have to multiply x minus 2, x minus 2, because it's missing the x minus 2 term. For the second fraction, we're going to multiply x plus 2. X plus 2. Now, for the sum of these two will be a times x minus 2 plus b x plus 2. And this new fraction we have with a and b should be equivalent to our original one. Our original one is 1 over x squared minus 4. Of course, our denominator are the same, so the top has to be the same in order to have the same fractions on left side and right side. So that means the top here is 1. The whole numerator for my fraction also must be 1. So a x minus 2 plus b x plus 2 must be equals to 1. The first way to solve that is we substitute numbers we want. Of course, the numbers has to be good for us to solve the problem. So the numbers we choose is trying to get this term to be 0 or this term to be 0. In order to have the first part to be 0, I have to give x equals to 2, because a 2 minus 2 plus b, now x is 2, 2 plus 2 equals to 1. Here is 0, because 2 minus 2 is 0, so the whole thing is 0. I have b 2 plus 2 equals to 1. So b is 1/4. We're gonna do the same for the second term. In order to make a second term to be 0, x must be -2. So we're gonna apply -2 for the equation right now. So 2, -2 plus, I'm just gonna write it even I know it's 0 equals to 1. So this is gonna be a 0. Now I have -4a equals to 1, and a equals to -1/4. Now our integration will be, for the first fraction, x plus 2, our a is -1/4. I'm gonna put in front. I have a 1. Plus, for the b, I have 1/4. I put in front. That's gonna be 1 x minus 2 dx. This is very easy to solve. This is very easy to solve. That's the reason we are using the partial fractions to help us. Now we're going to work on the second method. The second method is we look at a times x minus 2 plus b times x plus 2 equals to 1. I don't know what a and b is. That's what we're looking for. What we're gonna do is we're gonna open the parentheses. So we're gonna multiply a, we're gonna distribute it with b, so that's gonna be ax minus 2a plus bx plus 2b equals to 1. I'm gonna combine like terms, ax and bx. That's gonna be a plus b x negative 2a plus 2b equals to 1. Let's look at our terms right here. All right, for my right side, no x term. but these two left side and right side are the same. That means we should not have x term on the left side. How can we have no x term on the left side? The only way to have that is a plus b equals to 0. So we know a plus b equals to 1. Now, how about negative 2a plus 2b? Negative 2a plus 2b must equals to 1 because that's our constant. I'm gonna write it. So negative 2a plus 2b must be 1. Now we have two equations. That's gonna be system equations for us to solve. Now in order to solve that, we can times the 2. Right, then add up these two equations. So 2a and negative a cancels out. Now we have 4b equals to 1. Now we can solve for b. b is 1 over 4. We substitute back into the first equation because a and b has to be 0. Now I know a equals to negative 1 over 4. So this method right here can also help us to solve a and b. On the exam, it's your choice to pick the first method or the second method. Why we have two methods? There has to be a reason for that, right? First method is pretty easy, but there might be some problems we not able to do it by the first method. The second method kind of complicated, but we can solve all type of problems in the future by using the second method. So far, you don't have to worry. In case you have a problem for partial fractions, we're gonna have a review section for partial fractions for our school. So there's gonna be one professor teaching you guys about the partial fractions. So you can go to that section too. The section is for both our class, pre-calculus, and a student taking Math 206.5. Let's do one more practice on the partial fractions, since a lot of you are asking. Right, so let's do one more. I'm just gonna free write. We're gonna check what type of method we're gonna apply to this problem. First, you pry. It's not gonna work because it's too complicated. Denominator we have. Then we check the degree. The top numerator, the function degree, the highest degree is there's no x, so that's going to be 0. For my denominator, the highest degree will be x squared times x to the third. Right, so since the top is lower than the denominator, so we are first to find out if we can do the factoring. Oh, that's probably easy because we already done factoring, so it's already given as a factoring. So we're gonna have two fractions come out: x squared plus 2 plus the second one, x plus 2. So I'm gonna put the 3 in front. Now we have to sign the numerator. So the first one, since this is x squared, we have to give x plus a b. The next one will be c. Now we're gonna create our numerator right now. So when I combine, that's gonna be x plus b times x plus 2. Right, if you consider this is, I'm not gonna say this is like a cross multiply, but it's not cross multiply method. Right, so that's gonna be giving me the first term plus, next one will be c times x squared plus 2 . So that's everything divided by x squared plus 2 x plus 2. I don't have to write this, right, but I just want to show you this whole thing should be equals to 1 over x squared plus 2 x plus 2. I already put the 3 in front, so I'm gonna forget about 3. So now I basically have 1. Right, this 3 is in front right now. This means we're gonna have ax plus b times x plus 2 plus c x squared plus 2 equals to 1. Let's try our first method. So can anybody tell me what is the x I can use to plug in? So a lot of you tell me -2. Let me try that. So I'm gonna plug in -2. The -2 gonna help me to make this to be 0. So I'm gonna have a 4c equals to 1. I did it very fast, right? Because this square is 2. I made a mistake. That's gonna be 6. Because -2 squared is 4. 4 plus 2 is 6. So 6c equals to 1. Now I get a c. c is 1 over 6. How can I get an a and b? What else I can give for the x? So for the second term, we have x squared plus 2. It cannot be 0. Alright, so now the question basically is, can we make x squared plus 2 equals to 0? Then we're going to have x squared equals to negative 2. We cannot have a square equals to negative 2. Right, we don't have imaginary numbers for integrations because we are a real number system right now. So this is gonna be hard. So you can try different numbers you like. I think you can try 1. You may try 2, right? Or you can give 4, 3, whatever you like, to try to see if you can get new equations to solve this problem. Now we're going to try the second method. Alright, so the second method, this is question mark for you to try it at home after our class today. Now we're going to do the second method. Second method is we have to open it. Right, so that means I have to do a lot of work. So now let's do the first part. That's going to be ax times ax squared plus 2ax plus bx plus 2b plus cx squared plus 2c equals to 1. Alright, we still have the same idea. On the right side, there's no x squared term, there's no x terms. So now I combine x squared terms, a plus c x squared plus 2a plus bx plus 2b plus 2c equals to 1. Compare this left side, right side. I know this has to be 0 because right side has no x squared. This has to be 0 because right side has no x. And this part remaining must be 1. Maybe we can combine those two methods because I already have a c. Right, I have a c right here, which is 1/6. That means in order to have this part to be 0, a has to be negative 1/6. However, I just want to continue this method, right? So what we're going to do is basically we're going to set up the system equations. So a plus c equals to 0. 2a plus b must be 0. And 2b plus 2c equals to 1. So you solve this system equations because it's 3 equations for 3 variables we are able to solve. Right, so this can be solved. After we solve, we can easily plug in back into our problem and get a final answer done. Now let's move on to integration. 1 over x squared dx. So the problem we had before is x squared plus 4. It's very similar because we know no matter it's plus 4 or plus 1, we are not able to do the factoring. So this is not a partial fraction problem. So let's just go online and check. If you search online, Google it, you will get something special come out. This will be tangent x negative 1. So tangent x negative 1, everybody know that that's going to be an inverse function, right? That's r tangent plus c. By looking at this, can you guess what is 1 over 4 plus x? You can Google it, right? You can find the integration machine on the Google and solve for you. And everybody knows you can still download Maple software at home. I'm gonna send you a link so you can download it, so you can easily to check your work by plugging the function into the Maple and solve it to help you to understand if your answer is right or wrong. When you put this into any calculator, you will get 1/2 arctangent x over 2 plus c. Now I want you to guess what this gives us. 16 plus x squared dx. I don't know how you get the right answer, right? So it's basically about the 16 we have. 16 is 4 squared, so we're gonna have 1 over 4 to be used. So This means if I have a formula for this, let's see, that's going to be a squared plus x squared. A squared is a constant number. Right, so this one right here, so 16 is 4 squared. That's going to be 1 over 4 tangent arctangent x over 4. So that's basically 1 over a unique number I have right here, tangent x over a plus a c. Now my question is, if I have a 3 plus x squared, what I'm gonna get? We need a perfect square for this, right? The 3 is not a perfect square, but can we write something as a square for 3? So in order to do that, let's see, somebody already found out. We can write this as square root of 3 squared plus x squared dx. So now we can get it, that's going to be 1 over square root of 3 arctangent x over square root of 3 plus a c. Let's do one more. How about I have 5 minus x squared dx. Let's back to our topic and the beginning. Our topic and the beginning, I write it. X squared minus 4 x squared plus 4. X minus 4, x squared plus 4. We already understand that x squared plus 4, we can use arctangent. X squared minus 4 is different squares, partial fractions problem. So this is not give us the arctangent. Because we have a negative sign. This is not the formula we're going to use for arctangent. Arctangent formula is not applied to the problem for 5 minus x squared because we can factoring 5 minus x squared. Right? Whenever we can do factoring, that's not going to be the problem for arctangent. So arctangent must have a perfect square, adding a perfect square. One is your variable x, and one is a constant number. Now let's see a new problem we have. We follow the same idea, right? So let's see, I have x squared the new problem I have is 1 over x squared plus 2x plus 5. So of course I can try u prime. U prime is 2x plus 2. Does not work. Then I'm gonna think about, okay, the degree is 1. So how about partial fractions? X squared plus 2x plus a 5. It's not gonna work, right? Because 5 can only be 5 times 1 or negative 1 times negative 5. I cannot get the middle term too, so I cannot do factoring. This is not partial fractions. What else I can do? Now we are doing completing the square. We're just going to complete the square first, then back to the integration problem. So that's going to be x squared plus 2x plus a 5. Okay, let's see how you're going to complete the square right here. So x squared plus 2x plus 5, that's a leading coefficient is 1, so that's, I'm not going to write it, that's going to be bx plus a c, and this a here, a is 1. So we are looking for b divided by 2 squared. So b is 2, c is a 5. I'm going to plug in b2 right here. We need a 1. I don't have 1, but I have a 5. So one way to do it is I first gave a 1, then I subtract 1. That's exactly what we did before, adding and subtract. Then I still have 5 right here. Right, so now I did a perfect square right here. That's going to be x plus 1 squared plus a 4. Now we use this completing square back to our integration for the fraction we have. Right, so integration of the fraction, that's 1 over 4 plus or x squared plus 4. That's gonna be the same. I'm just gonna write this like square plus 4. Now can you tell me how I'm gonna use the arc tangent to do right now, because I have x plus 1 squared plus 2 squared because I have perfect square plus a perfect square. I think I'm able to use the arc tangent formula to finish it. You may easily think about, since we have x squared before, so I can just bring x plus 1 to replace the x we had before. Remember, we have a function u. Alright, let's say I give a function u right here. I'm doing the u substituting right now to show you how it's gonna work. Alright, so if I have a u equals to x plus 1, x plus 1 is very special. If it's 2x plus 1, something gonna be different come up. Right, so u is x plus 1. Then I'm gonna take derivative on both sides. That's gonna be du equals to dx. So we're gonna replace everything by u. So here we're gonna have u squared plus 2 squared du. Now you can see very clear the formula we had before is x squared dx. Now I have u squared du. Now we can apply the formula right away. That's gonna be 1/2 arc tangent u over 2 plus c. Right, because our u is x plus 1, we have to substitute back our original x. That's going to be arc tangent x plus 1 over 2 plus c. So that's the only case we can either think about. This can be just plug in right here. But if this is not x, then we cannot really do it. Think about that, right? So if I have 2x, then I have to do u equals to 2x plus 1. Then there might be something changed in the future. Then we have to work on that. So let's try one more problem for working on the completeness square. Right. I'm just gonna assume I tried all the method and it won't work. Only thing I know right now is we have to do completing the square. Right, we're starting completing the square. For 3x squared plus 6x plus 8. So it looks like it's very hard for the completing square because our leading coefficient is not 1. So I first gonna do is factor out the 3. So we're gonna have x squared plus 2x plus 8. We're gonna do the same as in order to get the constant we are looking for will be the middle term divided by 2 squared, which is gonna be 2 over 2 squared 1. Alright, so right here I plus 1, I subtract 1. Now this is the only way we can do right now because it's going to be hard to do it because I have coefficient in front. So I have a 3x plus 1 squared minus 1 plus 8. Alright, let's do the calculation right here. That's going to be 3 plus 1 squared minus 3 plus 8, which give us 3x plus 1 squared plus a 5. Now after our completing the square, we're going to have 1 over 3 x plus 1 squared plus a 5. Now we need to figure out how can we have variable square term plus a constant number term, right? When we have variable terms, we don't really have a 3 in front. So what do we do with the 3? If I don't want a 3 over there, what should we do? The 3 is our problem right here. I don't want it. I can divide it. When I divide it, everybody has to divide by a 3. Alright, so I can divide by 3 here. I divide it by 3 here to cancel it. I can divide it by 3 right here. Now we're gonna get a 1/3 1 over x plus 1 squared plus 5 over 3. This is not a perfect square, but we can make it perfect square. Now we have the format we want. We can get to the final answer. Think about the U substitution right here. It's not going to change anything. Right, I'm gonna write it right away. So it's 1/3 times 1 over a. That's gonna be 1 over the radical 5 over 3 arc tangent x plus 1 over a, that's going to be radical 5 over 3 plus c. Right. You can plug into the machine to see if we got right. That's how you check your homework answers. I'm going to send you the link of the Maple. So Maple is also the calculator you can use for checking the work. Today we just do a testing. So I'm going to stop our class right here. I want your feedback. How do you like it? If you want to continue this way doing for our class, we're going to do this every Friday at 1 o'clock. If you miss the live tutoring section, basically you don't have to worry because it's going to be put on the YouTube. You can watch later on, next anytime. Right, so the homework will be posted on the Blackboard. And if you like this way, I mean, of course, you may have something misunderstood I didn't go over because this is just a testing today, right? So I want your feedback. Tell me how do you like it, because online class do not have to be like this way. But I think this class is not easy for you to do it at home by yourself, just reading the books. So I want to show you step by step on the YouTube channel, right? So any questions so far? So for the first exam, I'm gonna post on the Blackboard. You can look at it, right? You don't have to worry too much about exam right now. We have to continue our topics because we have a lot of topics to cover. So I'm gonna email you what we're gonna cover next Friday. So the same time at 1 o'clock we're gonna start. You can also go to our 10 o'clock class. It's the same class, so you can first see some reviews I did. That's the same class. So we're gonna stop our class today. Any question you have, send me email, or we can discuss on the Blackboard. If you have any questions, just email me. All right. I'm gonna see everyone next Friday.